So this group is August and Chen. The topic we are going to talk about is 1.3, evaluating limits analytically. There are two targets we have to talk about. First is evaluate a limit using properties of limits. The second is evaluate a limit using dividing and rationalizing tactics.
So it's my turn. You can see here is a description of a function. The value of a limit can easily be evaluated by using direct substitution. The function is continuous at c, like this function. And there are some basic limits we will use in the next question. First is this function. This, if here is a constant, so then we can get a constant. Second function is like this. If there is a x or y, and then we can get just get this value c, and this is third basic function. If there is if his power is n, so we can get also get c, and then it has a power of n. Sorry, here are some examples. First, look at the question. We can now here it has a power of 3, so we can just use the third function, and we can get the answer is like this. Uh, second example. Here is a constant, so it just can get a constant, which is 23rd. Third example, and here is x, so we can we just can get a c, which c is 7, so the answer is 7. And the next is theorem properties of limits. Let b and c be real numbers. Let n be a positive integer, and let f and g be function with the following limits, like this. And we can get this list of function. This list function. We have 5 functions. First is pronounced like scalar multiples. It looks like this: b times fx, and it will be bl. L can be anything. L just the value of the fx when the x you use x in this function. And third is the sum of the difference. It looks like this. Look at this when you finish using this formula, and in the result also will be plus or minus, and then its product is very similar with second function. And fourth is quotient, or like this. What them looks like in the limits, and is keeps same in their result. And next is power. It's also like same way. And here is an example. That it is a basic function, and it has 3 functions. First, it asks us to get value of fx plus gx, and according to the function here, we can get we must use this function, second function. So it can be the value of fx plus the value of gx, so it's p at g. Then we look at this question. According to this function, we must use this formula. So hx is equal to 5, so the result is the power of 3, the 5 power of 3, so it's equal to 125. Then is the next last question. We need to use this function, as we can see, and then the denominator is the value of hx is 5, and the value over 5 must be fx and gx, so it's p and g. Here there is another question. Limits of a trig function. The limits of trigonometry function work the same way as normal functions. Typically, they can be solved by direct substitution and by using limits properties. Here is an example. Limits tangent x. First, we divided tangent x into this way: sin x and cosine x. But why here is c? Oh, sorry, maybe it's it's a small mistake. So here is 0. It's a 0. Then we put this 0 into x. This becomes sin x and cosine x. Then we can get this value 0 over 1. So the result is 0. Then here is the second question. Limits x cosine x and x is equal to pi. So we can directly now x equal to pi, so it has pi, and cosine x has cosine pi, and then cosine pi is equal to -1, so the result is negative pi. And the third question. Limits sin square x and 1x is equal to 0. Here, put 0 into x, and we can get sin 0 and a square. Sin 0, because of sin 0 is equal to 0, so it just be 0 square, so it is 0. According to this knowledge, we can find in the limits of a rational function. Like the first question, limit, like this question, when x is equal to 1, so we just put x equal to 1 in this function directly. We can get 1 plus 1 plus 2, so it's equal to 4. And on the line, here is 1 plus 1, so it's 2. So the result is 4 over 2 is 2. And the second question is like this. We divide this function into two functions. First is x minus 1, and next is x squared plus x plus 1. And on the line here is x minus 1, so cancelled. We just the thing only believed is x squared plus x plus 1, and then we we put x equal to 1 into x. It's 1 plus 1 plus 1, so it's equal to 3. The third question is the limit when the x equal to 0 and here is a function, and we use a special method like this. This function, the result of this function is 1, so it's okay to times this value, but the things that is special is here. We need to use a formula, a minus b times a plus b is equal to a square minus b square. Oh, but we can use this here. We just times them directly, and we can get this value. The root of x plus 1, and here is a square because it's 2. Here's 2 function. Here's 2, and get this, and on the line we can get this because x times this value. And in the next step, plus 1 cancelled, and because there's minus 1. So here is only a x, and the denominator keeps same. And in the next step, we cancel the x, so it's only have this value. Then we put x equal to 0 into the function. So on the root we just have 1 and plus 1 over 1 over root 1 plus 1 is equal to 1 over 2. So that's all the classwork. And in the next step we will talk about the homework.
So the homework page from 67 to 68, and here are some question numbers. And the first question is limit x to 1 and x over x squared plus 4. And these are the questions. Let's talk about the first question. So we substitute 1 into x and to the formula, and we get 1 over 1 to the square plus 4, and which is 1 over 5. The second question, we put 7 into the function, so we get 3 multiplied by 7 and over the root of 7 plus 2, and we get 9 under the function, and we get 21 over the root of 9, and we get 21 over 3, and we get 7. And for this is a trigonometric function for limit, and the x is pi over 2, so sine pi over 2 is 1, so we just get the result. For 29, x to 1, so on the top of the function, pi x is equals to pi, so we got cosine pi over 3, and we got 1 over 2. And here is secant 2x, and x is equal to 0, so we get secant 0, and we got cosine 0, 1 over cosine 0, and 1 over 1, which is 1. And next, sine x, and x is limit for x is 5 pi over 6, and we substitute it into the function, and we got 1 over 2. And tangent, x is equal to 3, is the limit for this is x to 3, and we get 3 pi on the top and over 4 on the denominator. And tangent is equals to sine over cosine, so this is equals to sine 3 pi over 4 and over cosine 3 pi over 4. And sine 3 pi over 4 is and uh uh and that's maybe the result. And for 23, fx is equals to 5 over x, and gx equals to x of 3, x to the power of 3. And a, we must get limit of fx, which x is the limit for x is 1. So we just substitute 1 into the function and get limit of x to 1, 5 minus x equals to 5 minus 1 equals to 4. And for b, the limit of x to 4 of gx, and this function is limit of x to 4 x to the cube equals to 4 cubed, which is 64. And for limit of g of fx, we first get fx, which is f function of f x equals to 1. So we get 5 minus 1, and which is also 64. And for 25, fx equals to 4 minus x squared, gx equals to root of x plus 1. And a is limit of x to the 1 fx, just like the question 23. And this we substitute x equals to 1 to the function fx, and we get 4 minus 1 to the 1 squared, which is 3. And for b, we have x to 3, and we substitute 3 into this gx function, and we got 3 here. So 3 minus 3 plus 1 is 4, and we get 2 as a result. And the last one is g of fx, and we get this into this function and get fx and substitute into gx, and we get g3, which is just like the question B, and we got 2. And for this 37, limit x to c fx equals to 3, limit x to c gx equals to 2. And for a, limit x to c 5g of x is equals to 5 multiplied by 2 is equals to 10. And b is fx plus gx, and we just get because this is a plus, and we just can get this result fx and gx separately. So we get 3 and 2, and we just plus them together, add them together, and we get 5. The same for this. There is a multiply and between them, so we just get 3 here and 2 here, and we got 6. And for d, this is quotient, and fx is equal to 3 and gx is equals to 2. So we just divide them and get 3 over 2. For 78, limit x to c 4 multiplied by fx. Fx is equals to 2, so 4 multiplied by 2 is 8. And the same for the questions below. This use the property for limit of adding, and this is multiplication, and this is quotient. So we just substitute c into fx and gx, and like here we get 2, and here we get 3 over 4, and we add them together, and here we multiply them together, and here we divide them, and we get the result. And now we must have this, and limit x to 0, x over x squared minus 4 is equal to 0 over 0. This is a 0, 0, and limit of x to 0, x over x multiply x minus 1, and 1 over x minus 1, and which is negative 1. And here we get limit x to 4, x minus 4 over x squared minus 16, which is 0, 0. And we have to know that this is x minus 4 multiplied by x plus 4. These are the factors of this this one, and we get x plus 4, and which is 8 at the bottom, and we got 1 over 8. And here is we can get that this is a 0, 0 condition too. So this is 3, and this is 3, negative 3. So we have their square, and we get 0 over 0. So we must have their factors, and we get x plus 3 multiply x minus 2 over x minus 3 multiply x plus 3. So we just divide these two. This is equal to 1. So we get x minus 2 over x plus 3. This is 5 over 6. And the same for the 53. We get x to the 4th limit, and 4 minus 5 is 9. And here on the top we get 0. X minus 4 is also 0, so we got 0 over 0. And so we must have to multiply this. This is 1. So on the top we have this is x squared minus y squared, and we get x plus 5 divide minus 9. So this is x minus 4. And here so we just divide here. Yes. And we get 1 over x plus 5 root plus 3. And we get 1 over 3 plus 3. This is 1 over 6. And 96, this is a answer here. And indeterminate form is an expression that cannot be evaluated. 0 over 0 is an example, and there is another example that like infinite over infinite is another example. And that's our presentation. Thanks.